Okay, on your desk, you should have your multiply decimals maze from RTI. If you have a star at the top, you got full completion points for that. All you had to do to get the completion points was to attempt the problems and show work. Next thing I want to talk about is the weekly worksheet. I'm going to go over some of them that I want to go over, and then if you have questions over any of them, I can go over more. Arabella, put your computer away right now. Don't need it. So I'm going to go over problems 6, 7, and 8. 6, 7, and 8. 8 was not 8, 9. 6, 7, and 9. 9 was the most missed problem. I'm going to start with it. And that's why I put it on there, because it's not that it's difficult, it's that we forget the rule. Anything to the 0 power is what, Dylan? 1. Raise your hand if you forgot that. That's why it was on here. Anything to the 0 power is 1. So what's 17 to the 0 power? 1. What's 14 to the 0 power? 1. What's negative 7 to the 0 power? 1. What's 3/4 to the 0 power? 1. Anything to the 0 power is 1. What would the power have to be for me to get an answer of 7? Kylie? 1, because that just means I only have 1 7. This means I have 0 7s. But it has to be 1 because in longer problems, if I had like this, 6 cubed times 7 to the 0 power. This has a value of 1. This doesn't go away. I still have 3 6s, but that's why it's 1, because if I multiply by 1, does it change that value? No. Okay, so this says I have 0 7s and 3 6s, so that would be 216, not 0. If it was 0, it would cancel out everything, and we're just saying I don't have any 7s. Okay, number 9 was the most missed problem. Not that some people didn't get it correct, because several did. Number 6 and 7, a lot of people got it right, but a lot of people made it way too hard. 5, 3, 7, 4.3 divided by 1,000. If you set it up using long division, you made it too hard. Easton G, what is the easiest way to work out that problem? Not to do long division. If you did long division, you can get the right answer. It's just you made it too hard. Zach?
Dividing and then like 5,000 divided by 1,000 would be 5 and then 300.
Nope. You're overthinking it. Emma, you move the decimal point how many times?
3.
Which direction? Why are we moving it to the left? Arabella? Because we're dividing by powers of 10. So on this one, really all you had to do is count. I'm dividing, so I'm moving left 1, 2, 3 times. So I move it 1, 2, 3 times. So my answer would just be 5.3743. We can't leave off that back 3. Okay, raise your hand if you made that one way too hard. Okay, there were lots. Number 7 was the same type of problem, or a similar type of problem. What do we do when we're multiplying by a power of 10? Dylan?
Move the decimal to the right.
To the right. How many times on this one? Twice. 1, 2 zeros in my problem. I'm going to rewrite it so I don't get into the problem. 1, 2 times. What do I put in my empty loops? Chloe? Zeros. So this would just be 30. Okay, again, those were probably the most missed problems on here. Some people did forget on 12 and 13. To add and subtract fractions, you must what? Must have a common denominator. Must have a common denominator. On 10 and 11, a lot of people got them right. Let's talk about what would we have to think about on 10 and 11 to get them in the right order. Easton? What? Read carefully. Okay, hey, close your Chromebook. We don't need Chromebooks right now. We don't need them at all today, actually. So, what's important? How do we decide what number goes first in our problem? Emma?
Like
Okay, let's look at our question. What are our 3 important words in that question? How much water was in each balloon? Waylon?
Water each balloon.
Yeah, water, each balloon are our 3 words that help us figure out the problem. What do we know about water in the problem? What do we know about water, Kylie?
There's 6 liters.
There are 6 liters of water. Each is where I put my divide sign. How many balloons, Emma? 20. 6 divided by 20 without doing any math at all is 6/20. Caleb, is that a good answer if my answer is a fraction?
No.
What's wrong with it?
It says that the answer has to be a proper fraction or mixed number.
Okay, it is a proper fraction, but why is it not my best proper fraction? Because it can be simplified. If I reduce them both by 2, I would get 3/10. My answer would be liters. So each each balloon would get 3/10 of a liter of water. Number 11. Aubrey, what are my important words in number 11?
Strawberry syrup each Sunday.
Yeah, so I'm going to do syrup each Sunday. In the problem, we have 5 ounces of syrup each. How many sundaes are we making? Guys, be quiet back there, please. Emma, 3. Why is it 3 and not 2?
Because it said he made it for himself and his 2 cousins.
He made it for himself and his 2 cousins with no math involved. That's 5/3. Is that my best answer?
No.
No. Audrey, what does that reduce to? 1 and 2/3. So 1 and 2/3 ounces of syrup for each Sunday. Okay, or do you have any questions over any of those? Those are the ones I wanted to talk about. But again, you guys did pretty good on these ones. A few people even had 5/3, but then when they flipped it to the mixed number, that's where they goofed up. You guys have questions over any of the other ones? Nope. Okay, set that aside. What do you think we're going to be talking about today? Callie? Dividing decimals. Okay? Pull out your little, the rules sheet I gave you that says dividing decimals on the left and the right. It's 2 different types of problems. What do you notice about those? What's different about those 2 problems? Because there's 2 different sets of rules, but they both say dividing decimals on them. Waylon, what's different?
On the first one, the number that you're dividing is the whole number, and on the second one, the number that you're dividing is the decimal.
Okay, so on the left side, the number we're dividing by is a whole number. Is that what you said? And the one on the right side, the number we are dividing is a whole number. Okay, and that could vary. Let's focus on the divisor of both of them. Waylon said on the left side, the divisor is a whole number. On the right side, the divisor is a decimal. Okay, that's the difference, the main difference in these. Okay, at the bottom of that piece of notes paper, I want you to make a little asterisk and put, you cannot divide by a decimal. So that means the divisor, we'll use the proper word, can't be a decimal. Colby, I need you to sit up. This is new and this is important. Put your hood down, please. Head up, hood down. So you cannot divide by a decimal. So the divisor can't be a decimal. Is anybody in here a magician? Or go to clown college? Make things disappear? No? Okay. So we cannot make decimal points disappear. You will see problems when it's given to you. The divisor is a decimal. So we have to adjust the problem. Okay? you must adjust, and I'll show you how in just a second, adjust the problem to make the divisor a whole number. Okay, so that's just going at the bottom of that decimal dividing notes page. That's just a sheet you can refer back to if you need it. Brennan, that's all. You could have just wrote that at the bottom down here. It's fine, as long as you have it somewhere, but if you remember that, everything else is the same as long division, okay? Just have to know what to do with the decimal point, which is what we're going to practice in just a second. So now, on your piece of loose leaf, I want you for notes today to turn it sideways. Why do you think I'm going to have you turn it sideways? Ty? So you can keep your numbers nice, neat, and lined up, because with long division, is that important? Yes. Okay, so on your loose leaf, I'll write mine down here. I want you to title it Dividing Decimals Examples. Okay, on your loose leaf, title it Dividing Decimal Examples. Okay, now I'm going to write it the way the book shows it so you know what to do. So the first example we're going to do, we'll just call it number 1. In the book, they write it like this, and I'm not going to fill it in the boxes just yet. How else could they have given me that problem? Because you need to be able to see it both ways. Emma?
48.33 divided by 3.
Yeah, 48.33 divided by 3. Okay, sometimes they'll give it to us like this. Sometimes they'll give it to us horizontally. Which number cannot be a decimal? Which of those numbers is the divisor? Arabella? The 3. Thank you. Okay, so that's the one that cannot be a decimal. Is it a decimal? No. No, so we can divide decimals. We just can't divide by decimals. So word problem to help you kind of understand what this is asking. If you have $48.33 and you're sharing it with 3 of your friends, how much does each friend get? Can you divide money into 3 equal parts? Yeah, most of the time. When can you not divide money into 3 equal parts?
When it's only dollar bills and it's not.
No, you could possibly do that. Kylie?
When it's like a penny.
Yeah, if you have 1 penny left, and can you divide a penny into 3 equal parts? No. In this problem, if that came out, we would have to maybe do some rounding to get to our final answer. Okay? So now let's set it up to work it. I'm going to move this up. I think everybody has that now. When we set it up, again, I want you to use the lines on your paper. I'm going to use the grids because I don't have vertical lines. Leave some space to show your work at the top. Put your answer at the top. Put 3 back on the outside. I'm only going to put 1 number in each column. Put your decimal point in the problem. Where does my decimal point go in the answer? Anybody read ahead on the notes? Aubrey?
It goes in the same place as the decimal in the question.
I don't like saying the same place because it won't always be in the same place. I think you mean it, but I think you're saying it incorrectly. Callie?
You just move it up.
You move it straight up, okay? Because just because there's 2 decimal places in my problem doesn't mean there's going to be 2 decimal places in my answer, okay? So we just say we move it straight up into our answer, into our quotient. So I'm going to show that this is moving straight up right there. And then once it's placed, we're done with the decimal point. We don't have to think about it as long as I line up my long division problem properly. So now we just do our long division. How many times does 3 go into 4? 1 time. Put a 1 above the 4. 3 times 1 is 3. We subtract and get 1. Noelle, what do I do next? Drop the 8. Noelle, how many times does 3 go into 18? 6 times. I get a remainder of 0. Cam, am I done? Why not? Because we have to drop the 3. 3 goes into 3. How many times, Ty? Once. Put a 1 at the top. 0. Drop another 3. Madison, now what?
That's your remainder.
Nope. I just dropped it. What do I have to see?
3.
How many times 3 go into 3? Once. I put another 1 at the top. Now, on these ones, when you do long division, I want you to write your final answer out to the side, circle it. So the whole world knows that's your final answer. Now, I'm going to pick on Madison for a second. We're not there yet. But we cannot mix decimal answers and remainders. We can't have an answer of like 16.1 remainder 3. Okay? We can either give our answers to division problems 3 ways. We can give it as a whole number with a remainder. We can give it as a fraction, like a mixed number or a whole fraction, or we can give it as a decimal. We can't mix and match those 3 forms. So we couldn't do like 16.1 and 3/3, like mixing decimals and fractions. We have to go all decimal, all fraction, or whole number with a remainder. Yes?
So if there is a remainder, do you add it to the...
Nope, we'll get there. We're going to do one like that. We don't do remainders. You will not have any remainders. We keep going till there's no remainder. Yes, we drop zeros. Okay, let's do another one. Call this one example 2. Let me find a harder one. They don't get too terribly hard. Let's do 12.4 divided by 8. 12.4 divided by 8, so when I set it up, 12.4 goes underneath, 8 goes on the outside. Before I do any math, I have to take care of my decimal point. Mila, where does it go?
You move it up.
You move it straight up into the answer, into the quotient. So let's move it straight up. Once we have it placed in the correct spot, we're done with it. We don't have to think about it anymore till we write it in our answer. Easton G, does 8 go into 1? Nope. Does 8 go into 12? How many times? 1. Where do I put that 1? Above the 2. Remember, this is where some people will mess up. They'll put it above the 1, and then all of their numbers will be shifted a digit. When there's decimals, that matters. That'll move your decimal point or your place. So put it, since we went into 12, I put it above the 2. 8 times 1 is 8. Subtract and get 4. Why should I pause? What do I pause for? Who remembers? Why do I pause, Aubrey?
To see if you can drop anything down.
Nope, not yet. Easton?
Make sure 4 is under 8.
Yeah, to make sure when I subtract, my answer is less than 8. If it's not less than 8, what does that tell me? Kylie?
You can, the blank can be...
Yeah, that number, my quotient should have been a little bit higher. Okay, but Aubrey was kind of processing what we're going to do next. We're going to drop the 4. 8 into 40, Caleb? 5 times, and since I dropped the 4, I put the 5 above the 4. Now, here's where I would get all kinds of crazy answers for this problem till we do one. I would get 1.5 remainder 4. Sometimes I might get 1.5 and 4/8. We don't mix what? We don't mix fractions and decimals, and we don't add remainders to fractions or decimal problems. So what do? Waylon?
You add a 0 behind the 4 and then you drop it.
Yeah, how many zeros can I add behind that 4?
As many as you want.
As many as we need. Okay, so we're going to add as many as we need. So I'm going to add 1, and I'm going to drop it down. Notice I'm adding zeros to my problem. When do I add zeros to my answer? When would I need zeros in my answer? Because what a lot of people do is they want to put them at the top in the answer. Emma?
When you have like a remainder after subtracting, and then you put it, and you can't divide it by your divisor.
Yeah, when whatever I'm trying to go end, whatever number I'm trying to divide into, it's not big enough. It's smaller than my divisor. Then I would have a 0 in my problem. What does my work show? Who remembers what my work shows if I'm going to have a 0 in my answer? A double drop. Which, remember, that means like if I drop the 4 and it's not big enough, then I'd have to drop a second number to make it big enough. So does 8 go into 40?
Yes.
How many times? 5 times. 5 times 8 is 40. So we get a remainder of 0, so we are finished. I'm going to write my final answer out here to the side. Now, in 5th grade, a general rule for rounding. A lot of decimals, when you're dividing, the answers can get ugly. Okay, most problems don't come out pretty when you do decimal division. General rule in 5th grade, what I have you do is if you get out 3 decimal places, see how we have 1, 2 decimal places? If we didn't get to an end point after 1 more place, we would stop and round it back to 2 places. So if we were doing long division, let me just make this, pretend this is 47. Okay, don't change yours. We would get 7 left over. We would have to add another 0 and drop it. 8 goes into 70 8 times. That'd be 64. I'd have 6 left over. See how I'd have to drop another 0? And it still wouldn't come out whole. This in 5th grade, I would let you stop once you get that 3rd digit and then just round it to the hundredths place. We can't just chop off, but we can stop and round it. That would still be a proper answer. Okay, I believe tonight they come out fairly pretty for you. Okay, let's do one more like that. The only thing they can get harder on in this lesson is the divisors can be bigger. So we're going to do one with a little bit larger of a divisor. We are going to do, I lost the problem, 145.8, this is number 3. 145.8 divided by 12. So let's set it up. Before I start doing any division, Easton, what do I need to do? Move my decimal point straight up into my answer, into my quotient. Now I just do my long division as normal. Zach, how many times does 12 go into 14? Once. Why did I go into 14 and not into 1?
Because 12 can't go into.
Yeah, because 12 doesn't go into 1. So I put my 1 above the 4. So then I get 12. Subtract. Aubrey, what's next?
How many times does 12 go into 25 and that?
Okay, because I had to drop the 5. Okay?
And it goes into it twice.
It goes into it twice, and I put that above the 5 because that's the number I just dropped. So that's 24. Audrey, now what?
You would drop your 8 down.
I'd drop my 8 down. How many times does 12 go into 18?
6.
Try again. 12 into 18. You're overthinking it.
Yeah, I know.
I think you need a reset. Go ahead and reset there. Zach? Once. 12 times 1 is 12. Madison, is my answer 12.1 remainder 6?
No.
Is it 12.1 and 6/12? What do I do?
You have to
I add a 0 to my problem because is 145.8 the same thing as 145.80? Yes. So then we drop it. Drake, how many times is 12 going to 60? 5 times. If you need to go out to the side and do some scratch work, you can to figure that out. We got to a remainder of 0, so we are finished. 12.15, final answer. Okay, so is that so bad? The hardest part is when you have bigger divisors. That's not it. It's close. That's not all we have. The other types of problems look slightly different. So example 4. I'm going to write it the way the book writes it, and then we're going to adjust it. Who can give me that problem in a different format? Emma? Yeah, 0.66 divided by 0.3. Which number cannot be a decimal? Emma Lapp? Emma E, sorry. The divisor. So in this one it's a 0.3. I don't care if you write it like, copy it if it's in the book like this, or copy it like this when you copy it down. I want you to copy down the original problem first tonight. Then we have to adjust it. Your notes page says, when the divisor contains a decimal, move the decimal point as many times as needed to create a whole number. Move the decimal in the dividend as many times. So we adjust the problem to where the divisor is a whole number. Let's look here. How many times would I have to move my decimal point to make that a whole number? Rory?
You move it 1 time.
Yeah, you move it 1 time to the right. So let's show that with an arrow. Now, so the dividend doesn't get jealous, we have to do the exact same thing to the dividend. So we have to move the dividend decimal point 1 time to the right. Now, mathematically, that is legal. Because what math did we just do if we moved it to the right 1 time? Emma? We multiplied them both by 10. So let's just think of a math problem we know the answer to. What is 6 divided by 1? 6. What is 60 divided by 10? 6. So when we multiply or divide by powers of 10, as long as we do it to both the dividend and the divisor, our answer will still be the same. It just makes our math to get to that answer a lot easier. So then we're going to rewrite this problem as 6.6 divided by 3, because I moved that over. So we copy down the original problem, we adjust it, we write our new problem. Now it looks just like what? Yeah, the ones we just got done doing. So now we just work it out. I'm going to move it back over here since I'm taking up so much space. So 6.6 divided by 3. Colby, how many times does 3 go into 6? Oh, what do I do before I start doing division? I move it straight up. Okay, now Colby, what do I do? Okay, 3 goes into 6 2 times. Tyson, am I done? Now what? I dropped my 6. How many times 3 go into 6? Twice. So final answer is 2.2. Is that much different? Nope. One more example. I'm going to do a harder one. Let's do number 4. Oh, number 5. 0.07 divided by 1.4. This is a problem a lot of students don't like when they look at it. Why do they not like it when they look at it? Emma?
Because
they're both decimals. What do you notice about that first decimal compared to the second decimal?
The second decimal has a whole number and the first decimal doesn't.
Okay, which just means it's a small number divided by a bigger number. Can we do that?
No.
Yes, it just means our answer is going to be less than 1. Okay, because 0.7 divided by 0.7 is 1. So we're dividing by a number bigger than 0.7. So we'll get a number smaller. Which one cannot be a decimal? Which one cannot be a decimal? Callie? The 1.4. So we have to adjust it to make it a whole number. How many times do I have to move my decimal point?
1.
I have to move it once over here to make that a whole number. If I move it over once in the divisor, I also have to move it where? Once in the dividend. Okay, so this one is still a decimal number. Is that okay?
Yeah.
Do I need to write 0.7? Nope. Now I have a problem that I can set up. So I'm going to set up my box. I'm going to leave some space to put my answer above it. 0.7. Put 14 out here to the side. Before I start doing math, Ty, I have to bring my decimal point straight up there into the answer. How many times does 14 go into 7? 0. It's not 2. Why is 2 a common wrong answer? Because 7 goes into 14 twice. But 14 goes into 7 0 times. So I have to put that 0 there. Now what? Callie? I add a 0. Go ahead and put 1 0 there. How many zeros can I add? As many as we need. Now, this is where we may have to guess and check. Do some work out to the side. Take a guess, Brennan. How many times do you think 14 goes into 70? 5. Let's check it out to the side. Okay. Did it go 5 times? Yes. Remember, we guess, check, adjust if necessary. So we put a 5 above the 0. We get 70. Do I need to drop more zeros? Nope. So my answer, what is the best way to write my answer? Kylie? Yeah, if I don't have a whole number, let's go ahead and add 1 in. Okay, does this make sense? Yeah. The hardest problems tonight will be the ones where the divisor is a 2-digit divisor. Okay, should we know how to divide by 2-digit divisors? Yes, but are they harder for us?
Yes.
Yes. Okay, let me stop this. I'm going to pass out your work.